write it all down. Alright, so the first thing I'm going to need to give you I'm debating between Z or T. So what is the thing that I'm looking for to decide if it's Z or T? So if we are given sigma, we use what?
Z.
Z star, I don't care. Technically Z star, I use it because in confidence intervals, it's always two-tailed, or it's always two-tailed, so it's positive, negative. I don't care if you write the star or not, but here it's actually not always positive, negative. So the shaded area is called the what? P-value. So to find the p-value, physically, paper in front of you, we use what? The z-table. Yellow sheet, z-table. Z-table would be more appropriate. Or how do you use your yellow sheet in a calculator? What buttons?
Second. Distribution.
Just finding the shaded area, not the whole test. Normal CDF. So like I said, I'm hoping this is a bit of an overkill. I'm hoping y'all are okay with this already. So I'm just going to make up an example. Let's do, hopefully you have a little bit more room than me. This 1.82. So if I want to find the area of that curve, and I go to second distribution, normal CDF, what do I plug in as my lower? What do I plug in as my upper? 1E99. And then we get a p-value of what? When I do that and hit enter, it gives me a p-value of what? So I've talked about these a lot here and there, but we haven't ever written this down, so I just want to take a second there. If it instead looks something like negative 1.60, and we're shading this way instead, what would I plug in as my lower?
Negative 1.
And there is a difference in your calculator between minus and negative. And then my upper would be
Negative 1.60.
and then when I type that in and hit enter, I get a p-value of
Just wondering, if you just did like 9 repeating,
if you just do what?
like 9 repeating instead of 1
Yeah, that's fine. Yeah.
But like, how would you do it negative? Just the first one I did?
Like to just do like negative 0.9, whatever, or negative 9, whatever, that's fine. So you would just, instead of everything with where I put 1E9, and you would just put a bunch of 9s. So you would still have a negative here instead of the first. So if it is two-tailed, did you ever say this at this point? Which means that the alternative hypothesis is what?
Not equal.
When we are just finding the shaded area, which is what we just did, whether we did it in the yellow sheet or in the calculator, we have to remember that we need to what?
But not when we do the calculator, right?
Not when you do a test in the calculator, but when you use what we just did, you would still have to multiply by 2. So if we are running a full test in the calculator instead, which means plugging in like my directional alternative, my X bar, all that stuff, then where would I go in my calculator? Over to, I can't remember if it's test or tests. And then here, when I'm doing a Z, it's which one? 1, which is just the test. So if I use that method, again, if it is two-tailed, swears it kind of is an overkill, which means it is not equal to, but I am running the full test in my calculator, then what?
What are we doing on your test?
Like you're doing, that's where it spits out your test statistic value, your area, your X bar, your S. It actually does what for you? Probably should change what you filled in. But it's actually, it does it for you. So just remembering the difference between those. Alright, so that was all stuff we did yesterday. Now, using T as opposed to Z. So first we're going to talk about doing it by hand with no calculator at all. I do not like this one. And I'm going to explain why. So I just gave you a fake example here. Our null hypothesis equals 5. Our alternative is greater than 5, which means it is one tail to the right. We did our work. We got a test statistic of 2.005, which means it looks something like this. If I am dealing with a T, what else do I need other than 2.005? So I use this and get a degrees of freedom of what? Because n minus 1 is degrees of freedom. The issue here is not all values are written on the T table like they are on the Z table. So look at your T table, and we know for a fact that we are in the horizontal line of degrees of freedom being 13. But we are looking for a value of 2.005. And it is not on there. So what are the two closest values to 2.005? And so this one filters out to a tail probability value of what? And this one follows up to a tail probability of. So all we know is that our p-value is somewhere between 0.025 and 0.05, which gets even more confusing if you now have to do a two-tailed, which this one isn't, because then we would say we have no idea. We just know that our p-value is somewhere between 0.05 and 0.1. And I think there ends up being a lot of have to think through hypothetically stuff with that, and I don't like doing it that way. You're absolutely welcome to. It works. I just don't like it. So I would suggest only doing this one in the calculator, but the process is the same as the way we just did it for Z. So just finding the shaded area, not a whole problem. Where did we go to just find the shaded area for Z? And we went to second distribution and then went down to what? Normal CDF. Well, we're not dealing with normal CDF, so which button do you think we're going to push now? And it is going to prompt you for these three things.
Is this going to happen every time we do T? It won't be on the table?
Right.
Okay.
So I'm still going my same example for right now, doing the 2.005. So I would plug in my lower as what?
2.0.
I would plug in my upper as,
1.
and for this same example that we just wrote down, I'll plug in my degrees of freedom of
13.
And that ends up giving us a p-value of what? And so now that I'm gonna have to compare that to an alpha, sometimes possibly multiply it by 3, I think it's a whole lot easier dealing with that than saying it's somewhere between here and here. Now I've got to compare to a range of values to a p-value, or to an alpha value. And I just think it's more confusing, and I think this is more straightforward, and I would choose to do this. But I'm showing you both, so I don't care which one you do.
Wait, how would you have done it by looking at the table and seeing what was in between?
So you would have just known that 2.005 is on the line of degrees of freedom of 13. We know that's a fact. It's somewhere between here and here, which means we only know that our p-value is somewhere between this number up top and this number up top. And I think that's a lot more.
That doesn't work out with what it is in something.
0.0331 is somewhere between those two numbers.
What happens if alpha is in between the two numbers? Like how do you?
Alpha values are usually ones that are like straightforward, but AP exam and stuff will do it to where like they'll pick an alpha value to where either method's going to give you the same answer, so they won't have to work. Like they would pick one of these that's the column, so you know it's either more than that or less than that. But theoretically, yes, it could happen. Alright, so again, repetitive here. If it is two-tailed, the way we just did it, then we are just finding the area. So either using the purple sheet or using TCDF in the calculator, we still have to multiply by 2. If we want to run the entire test in the calculator, that part should be really easy because it's very similar to what we did yesterday. Where are we going to go to run the entire test? And then over to and then again, it's two-tailed, which means it's not equal to doing the entire test in the calculator already multiplies by 2 for you.